Hello everyone and welcome to the first lecture of the AP Computer Science Principles course at CHS. A little bit by myself, I'm going to be one of your lecturers during the year. My name is Jan. I'm a current UCF student. I'm going to be graduating with a bachelor's in computer engineering in December 2020. I have a strong knowledge in both hardware and software development as well as their integration. I've been programming for around 8 years total, and I've been programming in Python for around 2 years. I am the current president of the IEEE HKN Theta Chi chapter over at UCF, and I'm going to be the volunteer lead in tutoring throughout this year. Now, I have a significant experience in software development as well as programming. I have recently finished up a internship doing embedded development, and I have been programming casually as well as in the academic sense for many years since I was around 14, 15. So I have extensive programming experience both in the in a professional setting as well as a private setting. Due to the current COVID-19 pandemic, we have decided as a team to suspend face-to-face meetings throughout at least the first semester of this year. We will be doing virtual lectures for team and student safety in following with the CDC guidelines. So this will affect how we regularly do these lectures. Normally it would come in face to face and we would teach in person. We have decided instead to do this video format in which we will provide you guys with videos each week. You watch these videos and we will attempt to lecture and provide all the material for the course within these videos. Now this is not ideal, and learning through virtually, I can understand that it is much more difficult than learning in person. Um, this is entirely a learning process, so this is something that we will have to work together towards. Any suggestions and any way we could provide our material in a more concise and easy to understand way, we are completely willing to hear out and implement if needed. Office hours will be implemented as soon as possible, in which we will be hosting either Discord or some other voice or video service meetings in which we can talk face to face in a virtual setting in order to help with tutoring or any additional questions. Now, there's no such thing as dumb questions. So what I really recommend everybody do after watching these videos, is to write any questions you have down and then provide them to Mr. Whaley or to the email that you will be provided for submitting questions. There's no such thing as a dumb question, so make sure you send them in and we will try to get to you as soon as possible. Alright, so I want to give you guys a quick introduction to this course. Throughout this course, you will be learning a whole lot of different things. It's going to function as an introduction to all facets of computer science. You're going to be able to design and evaluate all sorts of different software solutions. You're going to be able to apply CS principles to problem solving, as well as develop algorithms and programs to solve problems in general. The main thing you're going to learn from this course is how to use programming as a tool. Throughout this whole year, you're going to be learning a bunch of different programming concepts and a bunch of different, programming tools that you'll be able to use to problem solve just in general. I like you to think of this course and programming in general as a toolbox. And as we go further and further in through the semester and the year, you're going to be slowly adding more and more tools to your toolbox. And the more tools you have, the more kinds of problems you can solve in more efficient ways. And that's a very brief introduction to this course. The best introduction to this course, I believe, is just starting and learning and seeing what programming is actually like. Alright, so now I want to talk about the course expectations. I want to talk about what you guys can expect of the course and what I'm going to expect from you guys. So first and foremost, this course you can expect to gain a really good foundation in software development and just computer science in general. Like I mentioned earlier, this course will provide you the tools necessary to create all sorts of different programs and to problem solve all sorts of different problems using code and programming. Now, something that this course won't be able to provide you, you won't walk out of this course being able to make a game. I know everybody takes a programming course because they want to learn how to, make a game or something, but that won't necessarily be covered in this course. What this course will give you will be the tools to learn how to, make a game. The skills here will be necessary if you actually do want to make a game sometimes. At my internship, a significant portion of the programming I do isn't that much more complex than what will be covered in this course throughout this year. Now, I'll keep saying this because it is that important. Programming is really a toolbox, and the more tools you have and the better you are at using them, the better a programmer you are. So you'll be able to create all sorts of different things, and you'll be able to solve all sorts of different problems, but you need to be able to put in the work. Now, my team and I will be putting in a considerable amount of work trying to make this course as easy to understand as possible, especially in the current virtual learning environment. So we're gonna expect the same of you. We don't want, we just want you to try your best. We understand that everybody's best is different, but as long as you do your best, that is what matters in the end, and you will come out ahead, and you will gain some very valuable programming skills. Now, we heavily encourage teamwork. Teamwork makes the dream work, right? But what we don't encourage is cheating. I don't want anybody just blatantly sharing code, plagiarizing from each other, posting the problem online, and getting the answers from the straight up answers from Stack Overflow or checked. What we really encourage is talking through the problems with your peers and your friends and trying to come up with solutions together. That's perfectly fine, but I don't want anyone to finish an assignment and just hand in the assignment to all their friends. Now, programming in general is a very, it's an environment that really lends itself to teamwork. I've solved many difficult problems just sitting down with a student or a fellow engineer and just looking at the screen together, because something that really happens in programming is you get deep tunnel vision when you're stuck in a problem. So getting a fresh pair of eyes to look at it is a really considerable help. So we really encourage teamwork, but definitely not cheating. And there's a very fine line, and sometimes the line could get, blurred. So you have to be careful and just use common sense, and you'll be fine. Now, we again expect you to submit your own original work. If any of you are found blatantly cheating, copying from Chegg, copying from online, an entire assignment, there will be consequences. The administration will be informed, then it'll be their problem then. All right, so now that we covered all the administrative stuff, now we can get into the actual course content. Now, before we can actually start programming, we really need to try to understand what a programming language is. Now, that's a bit of a loaded question because you're not really going to understand what a programming language is until you actually start programming. Now, a good definition to a programming language is the following. It's a language in which people can provide very specific commands to a computer to achieve a goal. Now that's a pretty good definition. Now Wikipedia defines a programming language as a formal language that comprising of a set of instructions that provide various kinds of outputs. Programming languages are used in computer programming to implement algorithms. Now that definition, I feel like it's just a really fancy way of saying what the first definition. But for me, my definition of programming language is just a language that people can use to tell computers what to do in a very concise and efficient manner. Now, a programming language can be defined in a very complex way, but I don't think that would be a useful thing to do right now when you guys don't have the context for it. So what I recommend you do is just think of a programming language as a way to talk to your computer to get it to do something for you. And then as we go through the course, you'll be able to be more specific about that definition. And hopefully by the end of the course, you'll be able to provide your own definition of a programming language that fellow software developers and computer scientists will be able to agree with. So there's two main types of programming languages. There's compiled languages and then there's interpreted languages. Now, compiled languages are programming languages in which the code is converted from what is written into an executable before running. A couple of examples of these languages are C, Java, Haskell, and there are many others. Compiled languages tend to be the most common type of programming languages. Now, the second set, interpreted languages, are programming languages which are ran directly from the written code one line at a time. Now, this type of programming language is getting more popular in more recent times, and examples of these programming languages are Python, Perl, Ruby, among others. You can think of compiled languages as you writing down a set of instructions, giving it to a second person, which checks that the instructions make sense individually, and then after they've checked it, they provide it to a third person who then performs the instructions. The person who writes the instructions would be you, the programmer. The second person would be the compiler, and then the third person would be the actual computer running the program. You can think of interpreted languages as you write the program on a piece of paper, you write a set of instructions, and then you give it directly to the computer to run. The computer won't know if there's any problem in the code until they get to it. So it'll start running, and if there's any problem halfway through the instructions, that's when they'll encounter it. That's really the main difference between them. There's still a couple of more minute differences between these two types of programming languages, but those are the general differences. You'll learn more about the intricacies of interpreted languages as we go further into the course. Alright, so this is an example of a compiled language. Specifically, this is an example of the C programming language. All this program does is print out hello world to the screen. Now, whenever a programming language that is compiled wants to be run, you first need to compile the language, the code. You need to provide the compiler with your code, and the compiler would then run through your code and make sure there aren't any errors or any blatant errors. There aren't lines of code that are impossible in the program. The compiler would not check if the program makes sense or if it does what you want to do. It'll just check to see if it's possible to be run. Once it verifies all that, it generates an executable, which is then provided to the computer to actually run the program. Now, this is an example of an interpreted language, specifically it's Python 3, and this program does the exact same thing as the previous program in C, but it is a much shorter program, not because it's an interpreted language, but because those two languages are just different. It just happens to be shorter. Now, since Python is an interpreted language, what would end up happening is that the computer itself would go line by line, running each line pretty much live as the program is running. So you can think of this like a script where you just read one line, you do it, then you read the next line and do it, and so on and so forth. You cut out the compiler middleman that you normally have in compiled languages. Now in this course we'll be using Python 3 as our language of choice to teach programming. Again, as previously mentioned, it's an interpreted language, but it's also a very powerful language. It has been recently, in the past few years, been gaining a lot of popularity because it facilitates rapid prototyping and software development. If you're proficient in Python 3, you can get a rough prototype working of a very complex program within a day or two. Now this language was initially released in 1990. Back then it was just called Python. We're currently in Python 3. And it is a very powerful and versatile tool. It is a very nice language to have in your list of known programming languages. And by knowing a single programming language, switching between other languages or learning other languages is very easy because they all follow the same general structure and the general CS concepts apply. So the concepts you will learn in this class apply to every other kind of language out there. So don't think that the material covered in this class will only be useful for Python. Things learned in this class will be useful for programs such as C, Java, Ruby, any other kind of language. Okay, so now I want to talk about how we're going to get started in programming in Python. So there's two options you can use. You can use an installed desktop IDE. An IDE stands for Integrated Development Environment. It's just a program in which you can create your own code and your own programs and then run your programs from the same environment. The second option is to use an online IDE, such as Ripple. Now, I'm going to discuss both options, how to get set up on both, and during this course, you'll be able to use either for all the assignments and all the practices. And throughout the course, the lectures will be using both of them. Some lectures will be using Ripple, and then another lecture will be using the installed desktop IDE. Alright, so first we're going to discuss how to get started using an installed desktop IDE. First, you have to go to the following link to download Python in general, which will come equipped with the idle IDE. Now to get started with the desktop IDE environment, first you must download Python, and you do this just by typing Python 3 download into Google. The first result should be from python.org, so just click on that link and look for Python 3.8.5 and click on the download link. Afterwards, scroll all the way to the bottom and click on the Windows x86 executable installer. Now I already have Python 3 installed, so I'm not going to click on it, but once you click on it, your download should begin, and running the installer will start the installation process. At that point, just follow all the default options for the installer and wait for the program to install. So now once you have your Python environment set up, the way you access the IDE is just by pressing the Windows key and typing idle. Now once you've done that, you are going to be able to see the IDE in your list. Now you could add this to your start or your taskbar so it shows up down here, or you can just look it up every time you want to run it. Now once you run it, you'll be faced with this. This is the Python shell. This is kind of like a mini operating system in your computer that runs Python. You can run commands from here.
and they will run, and just like they would in a regular Python program. So if I press enter, that command just executed. But this can only do one command at a time. Like if I do 3 plus 5, it's gonna spit out 8. But that's not that useful if I actually want to write a program. If I want to write a program, what I should do is I should go to File, then New File, and now here is where I will write my program. Now the first thing you should do in this environment is you should immediately save. So you can do Control S or go to File and then Save, and then give it any name you want. I'm gonna name it Hello World. Now once you've named it, you can type your program up however you want. So let's say I want to print hello world, and then I wanna print my name is Jan. Now the print function that I'm using, it just prints out whatever message you put in it into the console. So if I were to save this program by doing Control S and then run this program by going to Run and clicking on Run Module, this can also be done by pressing F5. The program will run over here in its entirety. And this is pretty much how you use the IDE to do any sort of software development using Python. You write your program on a Python in the Python text editor. Then you do run and run module, and it'll run in the Python shell. You could again run individual commands over here. We could do print hello, and it will run it there, but here you can only do one command at a time, which is not as useful as being able to do however many commands you want in the program itself. Now that we discussed how to use a desktop IDE, we're going to talk a little bit about how to use an online IDE. To use an online IDE, you just go to a website that provides an online IDE and just use it. Now we highly recommend you use Ripple as your online IDE. Any other online IDE we won't be able to provide any help with. And anytime you wanna use an online IDE, Ripple is probably the best bet. Alright, so to get started with an online IDE, specifically Ripple, all you have to do is just go to the website. So you can either go to the website by using the URL, or you can just Google Ripple, and it should show up. It should be the first result. Now, I'm already signed in with my account, but when you get to this website, I highly suggest you make your own account. Sign up and make your own account, and this way you can access your programs from anywhere just by logging in. Once you've logged in and you've set up your account, when you go into Ripple, this is what the website should look like. Now, once you're signed in, I recommend immediately just going to all languages and looking up Python. It should show up early in the list, or if it doesn't, you can just type Python in, click Python. And then once you click it, you'll immediately start a project. And once you start your project, you can start coding. You could even see some examples. If we click here, here's some pretty cool examples that do some cool stuff. So if we click on Hello World, now we have Hello World here. Now we could run this program just the same by clicking Run, and then it runs over here. And this is the Python shell that we saw earlier in the desktop IDE. It's just over here. So if we were to do print and then like hello, it would also function here. We do 3 plus 5, 45. It'll also work just fine. The online IDE and the desktop IDE are completely equivalent, and whichever one you end up using is completely up to you. So now that you have your environment set up, let's actually write some code. Let's actually do some programming really quick. Now, I want to give you guys the bare fundamentals of input and output. We will discuss input and output in much more detail later on, but I just want you guys to have some tools so you can start playing around a little bit with programming and Python in general. Alright, so for this video, I'm going to be performing all of the programming using the desktop IDE. So for the next lecture, I will most likely use the online IDE to show you guys that they truly are equivalent. So now in a program, we might be interested in doing some input and output. So first, let's discuss the output a little bit. To do output, we have to call the print function. Now you may not know what a function is right now, and that's completely fine. We'll get into that a bit later. But a function is like a predefined list of commands that are written elsewhere that do work for you. So what the print function is going to do is I'm going to give it just a string of characters, so something like hello world. And once that function runs, it's going to take whatever's inside here and just print it out to the console. So if we save it and run it, we print hello world, and we can print out a lot of cool things. So we can print out, today it is very rainy. And then when we run it, the both messages will be played. Now, this is the output portion of input and output, and this is very useful, but sometimes we might want to give information to the program instead of just receiving information from it. And in those cases, we're going to want to use the input function. And what the input function does is that it asks the user for some information. So all you do is you type input, and then you write a message to the user. So something like, "What is your name?" And that message is going to be printed out to the console, and then whatever the user types in next will be grabbed. Now this function returns something to us, so we're going to want to save that. Now you might not know what that means yet, and that's completely fine. But whenever a function could provide a value back, or it could not. And in this case, input provides a value back. Input will provide back whatever the user typed into the console, and we're going to want to save that. So let's say let's name that username. So what ends up happening here is that this function occurs. This message is printed out to the console. The user types in whatever their name is, and once whatever their name is typed, this function returns and puts in the user's name into this into this container right now. This is called a variable. A variable is just kind of like a container. It holds data. Now, once we have that, we can actually do some pretty cool stuff with it. We could print out again, but this time we could say hello, and then we could actually greet the user by their name. So if you want to include a variable into a print statement with other strings, all you have to do is just separate all of the parts of the message with a plus like this. So now if we were to run this, we would, all right, if we were to run this, these two messages will be printed out first. Then this message will be printed out first, at which point we will give them our name, and then this final message with our name in it will be printed out to us. So let's save it and run it. Oh, there's an invalid syntax here. Oh yeah, so I forgot the plus here. All strings must be separated by a plus. So this is a string. This is a string right now, so there must be a plus between them. And then this is also a string, so there must be a plus between them. Now, string is just a collection of characters. It's like, a string is like words, like sentences. It could be a single word, it could be a single letter, or it could be a bunch of words together. So think of strings as like, just like that, a string of characters. Could be as short or as long as you want them to be. Now, if we were to run this, it's asking me what my name is. So if I were to put this, if I put Jan, it's going to greet me back. But here's the thing, I could run the same program again without changing anything, and I could say another name. I could say, what if my name is Richard? Now it says, hello, Richard. Or, hey, what if I say, what if I run it again and say, what's your name? Well, what if my name's Ivan? And it changes every time. And even though this is an extremely simple program, you can see how this could be very powerful, because every time you run it, something different could happen, because it depends on what the user provides. Now, the overall behavior is predictable, but the nitty-gritty details, the exact specifics of what each, run looks like heavily depends on what the user wants to do, which is, what really gives programming, the power it has. Now, this is a very, very basic introduction to input and output. We will discuss this much more in depth later on, but I just wanted to give you guys the tools to start playing around with this. So I want you guys to just start playing around with it. Put a bunch of messages, tell a story using print statements, then ask the user for their name, and then fill in the story with their own name. That's something you could do to practice using printing and input. That would be a really good exercise to make sure you're understanding this. But even if you don't, that's completely okay. That's what we're here for. If there's anything you didn't understand for this, please feel free to send all the questions you have to us, and we'll try to help you out with them. So this programming exercise was meant just to show you a really brief introduction. Again, we will go much more in depth later on. Now this brings us to the end of our lecture, and I have a few points I want to cover, as our conclusion. I just want you guys to be aware that you will gain very valuable tools in software development throughout the course of, this year. You will learn a bunch of stuff about coding, software development, debugging, all sorts of very useful skill in any sort of STEM related field. You don't have to be a software engineer to do coding. I know plenty of mechanical engineers that use code in their day-to-day life. And even if you don't strictly need to program in your day-to-day life, you can still do it to facilitate certain tasks, to automate some things you have to do that could be easily automated using Python. It also provides very useful problem-solving skills that easily translate into, other fields. Now, again, the most important thing that you should take out of this entire lecture is that there's no such thing as dumb questions. Please, any questions you may have, send them to the email on screen and we will try to help you through them. What I would like you guys to do in preparation for the next lecture is to just Google as much as you can about it. Look up YouTube videos, go on Google, and just try to learn as much as you can about Python. Next week, we'll cover some more topics. We'll go more in depth, but something that really helps with learning programming is to have the desire to learn programming, to have that curiosity. So if there's anything that really didn't make sense, or if there's anything you would like to know about programming, feel free to ask us or just Google it, look it up on YouTube. There's an almost infinite amount of resources available specifically for programming in Python, for people who are just starting up. Now, this is going to be a learning experience for everyone. We're all going to be learning here. You guys are going to be learning Python, and we're all going to be learning how to deal with a virtual learning environment. Now, I'd like to thank everyone for just attending, watching this video, and hopefully, we might be able to meet in person throughout the year or the semester. But if not, we will find a way to, to get this material to you guys virtually, just like this lecture was provided.